What's up, scholars? Today we're talking about 1.4, will be the unit. We are talking about, though, multiplying polynomials, which is basically doing the distributive property to polynomials. Okay, we're basically doing the distributive property. And we're just going to do a bunch of examples. So for your notes, write down these examples. Here we go. First example, we're going to multiply x plus 2 times negative x squared plus 3x plus 5. Now we need to multiply everyone in one parentheses by everyone in the other parentheses. So I'm going to get some rainbows going on here to indicate what I'm multiplying. X times negative x squared is negative x cubed. Alright, cool. And then I'm just going to do all kinds of crazy colors. It's going to be great. X times 3x is going to be positive 3x squared. Great. And then we'll do x times 5, which will be positive 5x. Alright, cool. We multiplied x by everybody in the second parentheses. Now it's multiplied 2 by everybody in the second parentheses. Okay. 2 times negative x squared is negative 2x squared. Now you'll notice I matched up the like terms together, so when I have to combine the like terms, they're on top of each other. It'll be a lot easier. And then we've got 2 times 3x. 2 times 3x is 6x. And then we've got 2 times 5, which is 10. Great. We multiplied everybody in the first parentheses by everybody in the second parentheses. And now let's combine like terms, add them all up. So, we've got negative x cubed in the front. 3x squared minus 2x squared is going to be x squared. And 5x plus 6x is 11x. And then plus 10. Et voila! C'est ça, c'est tout, that's it. Alright, great, let's do another one. Next question, 5x squared minus 3 squared. Can I distribute the exponent to both of these parts and be done? No! I definitely cannot. But I can write out this binomial twice and multiply. So let's do that. 5x squared minus 3 times 5x squared minus 3. Great. Now, let's get some rainbows going on. 5x squared times 5x squared is going to be 25x to the 4th. And then we'll do 5x squared times negative 3, which will be negative 15x squared. Great. Now let's do negative 3 times 5x squared. We'll get to negative 15x squared. And the last one, negative 3 times negative 3 is positive 9. Alright, we did the multiplying. Now we just got to combine the like terms. 25x to the 4th, that's the only one of its kind. So 25x to the 4th. Negative 15x squared plus negative 15x squared is negative 30x squared, and then 9 is all by itself. That's our answer. Alright, let's do another one. Alright, our next example, 7x minus 1 times 3x cubed plus 2x minus 1 times 3x squared plus 5. How are we supposed to do this? Now we've got 3 different sets of parentheses. I wish it was only 2 sets of parentheses. I could do that. Well, let's make it 2 sets of parentheses. Let's multiply these first 2 together, and then we'll multiply our answer by the third one. So we're going to ignore that last little dude for a minute, and we'll do 7x times 3x cubed to get 21x to the 4th And then we'll do 7x times 2x to get 14x squared. And then we'll do 7x times negative 1 to get negative 7x. All right, not too bad. Now, negative 1 times 3x cubed. Uh-oh, that's not a like term with anyone. Whatever shall I do? Well, it's going to go in between the x to the fourth and the x to the second, because we want to put our exponents biggest to smallest, so I'm going to kind of jimmy it in here. Negative 3x cubed. Okay, and then we have negative 1 times 2x. Negative 1 times 2x, that's going to give us negative 2x. I can put those two together because that's a like term. And then, let's do, what other color? I could do orange. Negative 1 times negative 1, that'll be positive 1. My poor orange is dying. Okay, so we multiplied two of these together. Let's see what we've got so far. 21x to the fourth minus 3x cubed plus 14x squared minus 9x plus 1. And now we need to multiply all of that by our third term, 3x squared plus 5. Here we go. It's going to be grand. 21x to the fourth times 3x squared. 21x to the fourth times 3x squared is going to be, what is that, 63? Yeah, 3 times 2 is 6. Great. 63. X to the 4 plus 2 is 6. Okay. 21x to the fourth times 5. It's going to be, 105x to the fourth. 105x to the fourth. All right. Doing great. Let's do negative 3x cubed times positive 3x squared. It's going to be negative 9x to the fifth, because 3 plus 2 with our exponents. So negative 9x to the fifth, and negative 3x cubed times 5. Negative 3x cubed times 5 is going to get us negative 15x cubed. Moving right along to, I feel like I'm going to have to reuse some colors. That will be okay. 14x squared times 3x squared. It's going to be a fourth. Oh, I should have used green. No matter, I can color over it. That totally looks green, right? What's 14 times 3? 3 times 4 is 2. Carry the 1. 42. That sounds right. 2 times 14 is 28. And 3 times 14, adding the 2, 42. Yeah, I'm here for it. Definitely here for it. So that's 42x to the fourth. 42x to the fourth. All right. Now we're going to do 14x squared times 5. Now I'll bring out the red. 14x squared times 5. Gosh. I don't know what that is in my head. I'm starting to get tired. Gonna bring out some tools. Also, let's just double check my last one. 14 times 3, 42. Great. How about 14 times 5? You know, I don't know my 14s very well, turns out. 70. What a nice round number that is. 70x squared. 70x squared. 2 more. I feel like we're doing great. Doing so well. Yep, totally reusing colors. I don't have that many colors. Negative 9x times 3x squared. Negative 9x times 3x squared is going to be negative 27x cubed. Well, goodness, that's a blue. That's my blue color. That's my x cubed. All good. What do we say? Negative 27 x cubed. And 9x times 5. Now I'm going to use the ink. 9x times 5 is going to be negative 40x. Negative 40x. Lost my marker cap. It's okay. Let's go back to the perps. Oh, it's a squared, so it's going to be 1 times 3x squared. So I'm using red, because that's my red color. 1 times 3x squared is 3x squared. And 1 times 5, 1 times 5 is 5. Alright, I did my best to stack my numbers. I got an x to the 6th, x to the 5th, those are my x to the 4ths, my x cubes, my x squareds, my x, and my 5. And now, the moment of truth, where we add all these things up. 63 x to the 6th, negative 9 x to the 5th, 105 and 42 should be 147. 147 x to the 4th, negative 15 and negative 27. I don't have it in me, guys. Don't have it in me for that. There we go. It's 42 again. Huh, wow. Negative 42 x cubed. 70 and 3 is 73x squared minus 40x plus 5. Oh, golly. That was exhausting. That was a lot of multiplying we had to do here. Lots of places to make possible errors. So, be careful with your signs. Make sure you're going through systematically. You're lining your stuff up. If you're me and you like to use different colors, use different colors. Don't forget to cap your markers back up. All right, great. Let's do one more example. Last one, last example. We have ax plus 3 times bx plus 2. That's going to equal 9x squared plus 21x plus 6. If a and b are constants, meaning some number, could be a fraction, could be a whole number, could be a negative number, could be a positive number, it's just a number. Find the value of AB, also known as A times B. All right. These two expressions are equal to each other. So let's multiply these two. It should be equal to this. And that'll help us figure out what A and B are, because these should match up at the end. And then we'll find what A and B are and multiply them together. So I'm going to bring this left half of the equation down. Ax plus 3 times bx plus 2. Let's do some rainbowing. And for the sake of time, I'm just going to use one color. I hope it's okay. Ax times bx. What is that? That is abx squared. Ax times 2. That is 2ax. All right. 3 times bx is 3bx. And 3 times 2 is 6. Do we have any like terms to combine? I mean, kind of. These both have x's. Ooh, sorry. These both have x's. So we could put these together if we wanted to. It would be ab x squared plus, you could pull out an x and do 2a plus 3b plus 6. Okay, does this look like our other half, or other side of the equation? I see the 6 there. We have 2a, which is a is a number, so 2 times the number plus 3 times the number. All of this would give us a number times x. Alright, fine, that's supposed to be 21. And then we have ab, x squared, and that's supposed to be 9x squared. But hold on, wait. The question just asked us for ab, finding the value of ab. We multiply this correctly. So ab is whatever number is in front of x squared, which is what? 9. We could be done there. ab is going to be equal to 9 because these halves of the equation, this whole gobbledygook that we came up with, is equal to 9x squared. So ab x squared is equal to 9x squared. So ab is equal to 9. We didn't even have to do that little thing. Not even required. All right, that is our multiplying polynomials lesson. Let's take a look back in time. What did we do? A ton of examples. That's what we did. A ton of examples of distributing, basically. You got to multiply everybody in one parentheses by everybody in other parentheses. Make yourself, or make it easy on yourself and stack up your like terms so that you can add them. If something is squared, you cannot distribute the squared. You must write this out twice and distribute everybody in the first parentheses times everybody in the second parentheses. If you have 3 terms you're multiplying together, multiply 2 of them, get an answer, and multiply that third one by the answer that you got. And finally, our goofy question, we used our same tactic, multiplying everybody in one parentheses by everybody in another parentheses. Boop, boop. And each side of the equation is equal. So the number in front of x squared, which we found was ab x squared, helped us find that ab equaled 9. All right, love you so much, scholars. That's it. Keep on that hustle, and I'll see you next time.